Hey everyone, welcome to SingularityComputers Client Build 7, Part 3. The name of this system is Dark Matter. The loop has been up and running for a couple of hours now. I'm still in the process of doing the leak testing. I do an 8-hour leak test for all of my client builds, and the system is just about complete. I just need to do a little bit more on the wiring and install the lighting. So there's not going to be a whole lot of action in this video. I'm just going to focus on giving you a good look around the finished product, and then I'm going to cover all of the test results. Okay, I've installed the lighting, finished the wiring, and I've also done a couple of other little things. So it's now time for a good look around the build. I'm going to start by answering a couple of the questions that came up the most on the previous video. First of all, people asked why I didn't use the water cooling built into the Asus Maximus 5 formula. For those of you who don't know, you can see a barb on either end of this heatsink, so you can actually use this motherboard air-cooled or water-cooled. Now, there's actually a number of reasons I didn't use it, but the first one is, take a look at my loop. I've used compression fittings, angle fittings, and these are barbs. They're ugly. Not only that, they are incredibly small. I think they must be 3/8 of an inch. Take a look at the internal diameter. It's actually a lot smaller than the internal diameter even of Crystal Link. And you know, people are often talking about the flow restriction of Crystal Link. This would be even worse. I'm not worried about flow restriction because I know it's really not a massive problem. I won't go into that now. The main thing I was worried about was the fact that to be able to use these barbs, I would have to convert down to 3/8. So that would mean I'd have to use a converter, which is fine. There's some pretty nice converters that Bits Power makes that don't take up much room. The aesthetics are good. But the thing is, they have threads on them, and there's nothing to thread into here. So I'd actually have to go down from a compression fitting or a multi-link fitting if I was to use Crystal Link to the converter. Then I'd have to go back to tubing, so using probably a barb or compression fitting, and then onto the barb on this heatsink. So there would be a massive mess of fittings and tubing, you know, all over the CPU water block, and it would look terrible. There was no way I was going to incorporate this heatsink into my water cooling loop. All Asus needs to do, and this is a massive recommendation from me to Asus, is install G1/4 inch threads instead of barbs. It would probably actually cost them less money to do this, and then it would be useful for everybody. Anyway, the other reason I didn't water cool the motherboard is because for this system it wasn't really necessary. I'd say that this motherboard wouldn't really benefit from water cooling until you push the CPU probably beyond 4.8 gigahertz. From the testing and overclocking that I did, I was hitting heat limitations with the CPU, and I was not having any problems with the motherboard at all. And you know, the CPU is water cooled, the motherboard is air cooled, so hopefully that gives you an idea. Now, something else I had a lot of comments about was how difficult it will be to remove the memory modules from this build. People were saying you'll have to drain the loop and dismantle it, but that's actually not the case. There's a big gap there. It's easy to remove the memory, and I actually proved this by swapping the memory from the black slots to the red slots. And this is something else I had some comments about. I had people saying I had the memory in the wrong slots, and it actually works fine both ways. There's no problem with having it in the black slots, but the thing is, Asus does actually recommend in the manual that you install the memory into the red slots when you have two modules. They don't give any proper reason though, they just say it will be optimal, which always annoys me, but no doubt Asus has their reasons. Now for a brief look around at the finished cable management. No doubt you've seen most of it by now. So I used a Corsair black individually sleeved cable kit with the Corsair AX750 power supply. The SATA data cables you can see there are all Bitfinex Alchemy Black 45 centimeter. This SATA power cable going to the optical drive I actually made from scratch, and I'm going to do a guide on this coming up. Basically, you have to have the wire, the pins, the connectors, the sleeving, the heat shrink. It's very time consuming, but it's actually not that difficult, which you'll see in my guide. Now the 6-pin PCIe I decided to bring up from the bottom because the graphics card is so short. It was just a whole lot cleaner than bringing it around from the side. I'll give you a look around the back of the build at the rest of the cable management shortly. So moving on to the lighting. As you can see, I settled on red lighting. I actually wanted to use white lighting, but as I've mentioned previously, I wanted to go for a dark and stealthy color scheme in this build. White lighting would have just been too bright. I also thought of blue, but that just clashed with the color of the case, which is gunmetal. It's like a greenish gray. So I also scrapped that idea, and really what's left is green or red. I obviously wasn't going to go with green. I mean, you could also use UV, but there's nothing UV reactive in the build either. So I ended up just going with red. And the reason I didn't want to go with red is because there's so many red and black builds, and people are just going to pick that up. But red by far creates the best aesthetics in this build, and that's what I have to think about. Now, you often see me using the same colored lighting as my coolant, and most of the time that's a bad idea, but you can get away with it and create amazing aesthetics if you create contrast, and I have talked about this before. Basically, it's quite simple. You just light up the areas of the build that you want people to see. So the water blocks, the reservoir, maybe things like that. And the parts of the build where the aesthetics aren't so good that you want to hide a bit more, you don't light up. Now you can see I've actually gone against this here because I've lit up the power supply and the radiators, which are components that you wouldn't normally light up. But I've actually designed this lighting taking into consideration the side panel. When the side panel is on, there's a nice soft glow coming from the top and bottom of the build. So that's the effect that I was going for. You can't really see that those components are lit up once the side panel is on. You can also see that I've lit up the CPU water block and the pump top. So all of the lighting is red. I've used two 3mm ModSmart LEDs in the CPU water block, two 5mm bits power LEDs in the pump top, and two 300mm Lamptron LED strips, one at the top of the build and one at the bottom. Okay, I've actually decided to install a fan controller for the radiator fans. I've installed the Lamptron Touch. It's a 6-channel fan controller, and there's 5 radiator fans. The reason I did this is because I've designed this entire system for a future graphics upgrade, including the water cooling loop. So this means that the water cooling loop is overkill for these components, which means the fans can be turned right down and you can still get, excellent performance out of the loop. So I wanted to give that option of complete silence and the headroom as well for the future graphics upgrade. And actually, for all of the testing and validation, I ran all of the fans in this build at 60%. And you'll see the results coming up. Now, I've actually hooked up the 3 case fans to the motherboard, and I've enabled automatic control of those fans based on, well, one of them is actually based on the coolant temperature, the other 2 are based on the CPU temperature, but basically at 40 degrees they're at 60%, and at 70 degrees they're at 80%, so they never go over 80%. So this build is incredibly quiet. It's actually so quiet that I couldn't even get a result on my decibel meter, which doesn't actually go below 30 decibels. So that puts this build somewhere below 30 decibels, I'd say closer to 20. I'm just going to give you a quick listen to give you a basic idea of the noise output. Now for a look at the finished wiring from around the back of the build. So I just quickly undid this cable. This is the one that I made up from scratch. The connectors are ModSmart. The sleeving and heat shrink is $1 Million PC black. So it's actually just an extension cable from Molex to SATA power. And the great thing about making up custom cables is obviously that you can make them to the exact length that you want. So I just tied up that cable, and I'm not going to spend too much time around here because I have already shown you the wiring. Since then I've actually added the lighting, which was a lot of extra cables. Actually 4 Molex connectors for the lighting. You can see 3 of them just there. And I also completely swapped around the fan configuration because originally I had some of them running off 12 volts, some of them connected to the motherboard, whereas now I have them running off the fan controller. Okay, now for the temperature results. Remember, without the ambient temperature, temperature results mean nothing because the ambient temperature directly affects the temperatures of the components. Now I'm going to put the results on the screen. First of all, I'll show you the stop clock results and then the overclocked results. Now for all of this testing, my ambient temperature was 30 degrees Celsius and I had all the fans in the build running at 60%. I also do all of my testing and validation with the side panels on. For the idle test, I cold boot the system and let it idle for 30 minutes, then I take the results. For the load test for the CPU, I run Prime 95 small FFT for 30 minutes. For the GPU, I run the Unigen Heaven benchmark for 30 minutes. Now for the overclock results, I push the CPU to 4.5 GHz, 1.25 volts. The graphics card, I only overclocked 50 MHz on the core and 50 MHz on the memory. I didn't want to push the graphics too far because I find most of the time with mid-range graphics cards, the biggest performance gains are before you start having to increase the voltage. Once you start pushing up the voltage, obviously you run into bigger risks of instability, the heat increases a lot, but the performance gains are minimal. Also, this system is getting a graphics upgrade, so there was no point in going all out with the graphics card overclocks. The hottest I saw the coolant temperature get during all of my testing was 35 degrees Celsius, so that's only 5 degrees above ambient, which shows that these components are hardly even having an effect on this loop. So some good results. Some of them were even hard to believe. The idle temperatures, I'm sure I'm going to be getting people arguing with me about those. The GPU, even overclocked, was idling at the ambient temperature. I was quite surprised. The overclock results, I was actually a little bit disappointed in the heat output of the 3770K. Now moving on to the performance results, which I'm going to show you in screenshots. Now, unfortunately, I couldn't get all the results, run all the benchmarks that I normally do, because I actually installed Windows 8 on Dark Matter and I ran into a bunch of compatibility problems. A lot of the benchmarks wouldn't even run. So I got all the results that I could. Obviously, with a bit of playing around, I could have got the other benchmarks running, but in the end, I had to ship the system. I didn't have any more time to play around with Windows 8. So not a massive increase out of the overclock, and that's mainly just because of the mid-range graphics card. Obviously, the more high-end the components are, the more of a performance boost you're going to get out of an overclock. So that actually concludes the Dark Matter build log. I'm now going to give you some information on Client Build 6, which is the Prodigy build, and Client Build 8. Now, the Prodigy build obviously got delayed a little bit. There was a couple of things that happened. The client wanted to swap a component, so I had to wait on that component, and the client's not ready to take delivery yet anyway. So I decided to work on some other projects and come back to the Prodigy later. Well, now that I've finished this build, I'm actually going to go back to work on the Prodigy, get that finished. There's still a lot of work to do. I need to modify the side panels. I need to do all of the wiring. And the wiring is a big job because I'm customizing all of the power supply cables. But anyway, once the Prodigy is done, there'll be one more video in that build log to complete it. And immediately after that, I'm getting started on Client Build 8. Now, I'm not going to say much, but it's going to be a massive undertaking. It's going to be an epic system. What I have in mind for it is just about beyond anything I've done so far, so I'm really excited about it. That sums up this video. Thanks for watching. Please subscribe, like and favorite if you want to see more.